Well, I thought it could be interesting to try and build a kit and explain how it works as we go. And as I was cleaning out my junk box today, I came across this unbuilt 49er from China. So we will do that and see how it works. Usually these Chinese instructions are pretty bad English. Like it was translated from English to Chinese and then back. So, don't think we actually want to read the circuit description. You can find the original one from N6KR is still online. The old NorCal QRP Club has some of the sites, so you can find the PDFs of the original. Let's see, bill of materials. Make sure we have everything later. But the schematic. This is the 49er schematic that came with the kit. I assume it's pretty accurate, but down here there's the power reverse polarity protection diode, so in case you hook the battery up wrong, the diode will conduct. These are capacitors will keep AC out of the power supply. Then only a few modules in the transceiver here. This is the audio amplifier. Here's a mute switch. This is the local oscillator right here. NE602 mixer. The front end filter. Here's the low pass filter to the antenna. The two-stage transmitter. You got a driver and the final power amplifier. And then this stuff here, these are for switching, transmit receive switching, and this is a little side tone oscillator. The original 49er did not have the side tone oscillator and did not have all this switching circuitry. The audio amplifier, just the standard LM386 circuit, looks like it was copied directly from the data sheet. The capacitor here between pins 1 and 8 sets it to maximum gains, which is a gain of 200. DC block capacitor on the output, a little low pass filter, knock down some of the hiss and stuff. Power comes in here, uses the single input. They got an LC filter here, help filter the input a little bit. Muting JFET here. When the key is closed, this diode is grounded and it will shut off the transistor, so you don't get the very loud transmitter going through. Then this stuff here is the local oscillator. The transistor for the oscillator is actually inside the 602. This is a pretty standard mixer chip used in a lot of QRP radios. This is just an 8-volt regulator for the chip. The input here goes through this crystal filter, so it should be a pretty narrow front end. It's got the standard back-to-back diodes for the transmit receive switch, and normally you have a capacitor inductor with the diodes, but here they put the crystal in. For the transmitter section, they just tap off the local oscillator, goes into the driver stage, the power amplifier, class C. These capacitors and inductor, low pass filter, might need an extra LC to knock it down. We can see when we build it. This is just a simple phase shift oscillator, it looks like, which gets injected in. When the key goes down, this will start oscillating and it gets put into the amplifier, so you get the side tone. The power for the driver comes through is controlled by this PNP transistor, and this other transistor here. You could use this for tuning, but it looks like it it just changes the voltage on here, which will change the capacitance on this diode a little bit, and gives you a transmit receive offset every time you key down. So it's a relatively simple transmitter. Probably the best way to build it is to start with the receiver, start with the audio amplifier. You can test it by listening to it, and then you touch your finger to the input and you should hear the noise increase. There's a lot of 60 hertz hum that you can pick up. And then just, install the muting circuit. Then you can build the mixer local oscillator section here. And once you do that, you'll have a working receiver, and you can hook it up to your antenna. You should be able to hear if anybody's transmitting around whatever crystal 7023 in this case. And once we get that all working, then we can build the two stages of the transmitter. Probably need to put in the transmit receive stuff here and the side tone oscillator if we want. So it should be interesting. So, in theory, this is the audio amplifier, and now we just need a way to test it. So, we'll be back soon with the way to do that. Well, if we look at the audio amplifier here, the C11 and R7 form a low-pass filter. We can do the math in a minute to figure out what the cutoff frequency is. So that means all the high-frequency hiss and stuff that comes out the output should get filtered out, and we'll have a cleaner signal. This is just a coupling capacitor. It'll remove any DC bias. If you read the data sheet for the LM386, if you put a 10 microfarad capacitor between pins 1 and 8, that will set the gain to the maximum value. I believe it's 200, and if pins 1 and 8 are left open, you get a gain of 20, I believe. But you can find that on the data sheet. 7 you rarely see used. 4 is the ground pin, whatever number this says. 6 is where power comes in. You can see VCC 12 volts. You got a little resistor to limit current. This capacitor is just there to remove noise from the any noise that gets into the power, like the battery, whatever. And then pins 2 and 3 are the input. Here we're just using a single input, so the output from the mixer comes in, it goes through this filter here, and then into the input. Keep the noise, high frequency noise off. We're only using one of the inputs, the other one is just grounded. So it's a pretty simple circuit. I've seen designs where you don't need the resistor if you're using maybe you only use 8 volts and go straight in, and they're confident that there's no noise coming in or not too much current, so they don't need the current loading resistor there. You can also get fancy and add some RC network to the pins 1 to 8, or even feedback from the output, and you can get more shape the gain, so you get more gain at lower or higher frequencies. But for most ham radio stuff, this is a pretty typical circuit that you'll see for the 386. I gave it some thought last night and realized there's a better way to test the audio amplifier and that one that doesn't require having a supply of 555 chips on hand. And you know, you can just touch the input, and your body will couple in 60 hertz noise and any other electronic noise around. So I have a speaker here attached. It's not very loud, the noise, so I don't think we'll be able to hear anything, but we will definitely be able to see it on the scope. So if I turn this on, there is nothing there. I'll zoom in a little bit. Then this handy dandy wire we'll use as an antenna, and if I come around and touch the input, you can see there's more noise, you know, amplified on there. We can zoom in a little. It's not very pretty, but there's definitely more noise. You can hear this, might be able to hear the speaker click every time I touch it. And if I let go of the wire, I couple in all less noise and it goes away. So the amplifier is working. So that's the simple and easy way to test that your audio amplifier is working.